we have discussed Laplace transform, introduction, and some standard Laplace transform. So today, properties of Laplace transform. So first property, so this property is known as shifting property. So what is that shifting property? So we'll discuss. If Laplace transform of f of t is equal to f bar s, so this is by definition, right? So then Laplace transform of e raised to at f of t, this is equal to f bar s minus a. A function f of t, it is multiplied by e raised to at. A function f of t multiplied by e raised to at. Laplace transform of e raised to at f of t will be f bar s minus a. Means a function multiplied by e raised to at. So Laplace transform of e raised to at f of t, this is equal to f bar of s minus a, or f bar s minus a. So this property is known as shifting property. This property is known as shifting property. Means a function f of t is multiplied by e raised to at. Laplace transform of e raised to at f of t is equal to f bar s minus a. Means s changes to s minus a. S changes to s minus a. Laplace transform of f of t is equal to f bar s. This is by definition. This function is multiplied by e raised to at. This function is multiplied by e raised to at. So this s changes to s minus a. This s changes to s minus a. So this property is known as shifting property, right? Now second one, Laplace transform of t raised to n f of t, means a function f of t multiplied by t raised to n. So n may be 1, 2, 3, 4, 5, so on. N may be 1, 2, 3, 4, 5, so on, right? So Laplace transform of a function f of t, if it is multiplied by t raised to n, this is equal to minus 1 raised to n d by nth derivative of this d by ds, or dn divided by ds raised to n f bar s, f bar s. In particular, if you take n as 1, you can take n is equal to 1, 2, 3, so on, right? So suppose you n is equal to 1, then in particular, if suppose n is equal to 1, so Laplace transform of t, f of t is equal to minus 1 raised to n. In place of n, 1 minus 1 raised to 1 d by ds. Nth derivative of this d by ds will be, n is 1 means here you will get here also 1 and here also 1. So this is nothing but d by ds of f bar s. If you take n as 2, so Laplace transform of t square f of t is equal to minus 1 raised to 2, because n is 2. So d square divided by ds square. In place of n, you substitute 2. D square divided by ds square f bar s, means you differentiate this f bar s 2 times. You differentiate f bar s 2 times. So here differentiate this f bar s 1 time. Differentiate this f bar s 1 time, right? This property is known as derivative of the transform property. So this property is known as derivative of the transform property, right? Next one is Laplace transform of f of t is equal to f bar s. So this is by definition. Then Laplace transform of f of t divided by t. Laplace transform of f of t divided by t, this is equal to integration from s to infinity, integration from s to infinity f bar s ds. So this property is known as division property, and this property is known as division property, right? So what is division property? So if f Laplace transform of f of t is equal to f bar s, then Laplace transform of f of t divided by t, this is equal to integration from s to infinity f bar s ds. So this property is known as division property, right? So using this, so we'll solve the examples. So first one, find the Laplace transform of e raised to minus 2t into bracket 2 cos phi t minus sin phi t. Right. So here first what is f of t we need to find. Right. So we have a properties. What is that property? E raised to at into f of t. Right. So what is then e raised to at? A is minus 2, right? And what is f of t? F of t is this. F of t is this, right? So I'll take f of t as this. So f of t is equal to 2 cos phi t minus sin phi t, right? So Laplace transform of f of t, Laplace transform of f of t, this is nothing but f bar s. So this is equal to 2, because 2 is constant, Laplace transform of cos phi t minus Laplace transform of sin phi t, right? So what is Laplace transform of cos at? S divided by s square plus a square. In place of a we have a phi, so s divided by s square plus phi square. So 2 will be as it is, minus phi divided by s square plus phi square. Why? Because Laplace transform of this sin at will be a divided by s square plus a square. In place of a we have 5. So simplify this. 2s divided by s square plus 25, because phi square is 25, minus phi divided by s square plus 25. Phi square is 25, right? Now we want Laplace transform of e raised to minus 2t into f of t. Why f of t we have taken? Because f of t is 2 cos phi t minus sin phi t. So instead of this, so we have written in place of this f of t. In place of this f of t, right? So this is equal to, so if a function f of t multiplied by e raised to if a function f of t multiplied by e raised to at, s changes to s minus a, where s changes to s minus a in f bar s. S changes to s minus a in f bar s. So f bar s is this, f bar s is there, right? So here change s to s plus 2, s to s plus 2, right? Why? Because the a is minus 2, because a is minus 2. Change s to s plus 2. Why? Because a is minus 2. So wherever s is there now here, wherever s is there now here, so replace s plus 2. S is there, replace s plus 2. Here also s square is there, s plus 2 raised to 2, and here also s square is there, so s plus 2 raised to 2, right? So this will be the required answer, right? Now move on to next one. Find the Laplace transform of e raised to minus t cos square 3t. So how it is? It is of type e raised to at into f of t. So what will be the f of t? So f of t will be cos square 3t, right? So f of t is cos square 3t. So we have a standard result of results for like Laplace transform of cos at, Laplace transform of sin at, Laplace transform of cos hyperbolic at, sin hyperbolic at, but we don't have a formula for this square, cos square, right? First you convert this in standard form. So we can write this cos square 3t as 1 plus cos 6t divided by 2. 1 plus cos 6t divided by 2. Why? Because we have a standard result, cos square a is equal to 1 plus cos 2a divided by 2. 1 plus cos 2a divided by 2. So in place of a we have here 3t. In place of a we have here 3t, right? So 1 plus cos 6t divided by 2, right? Next we want f bar s. We want f bar s. What is f bar s? F bar s will be Laplace transform of f of t. So Laplace transform of a function. So this is equal to 1 by 2. 1 by 2, you take it outside, Laplace transform of 1 plus Laplace transform of cos 6t, right? So what is Laplace transform of 1? Standard result, 1 by s plus Laplace transform of cos at. In place of a, we have a 6. S divided by s square plus 6 square, right? And this 1 by 2 will be as it is. So this is f bar s. This is f bar s, right? We want e raised to minus t, e raised to minus t into cos square 3t. We want, right? Laplace transform of e raised to minus t cos square 3t. So we have taken this as a f of t. So this e raised to minus t f of t. So this is equal to a function f of t. So this is multiplied by e raised to at. A is minus 1. Change s to change s to s minus a. A is minus 1. S minus of minus 1 will be s plus 1. Means here whatever s, wherever s is there, no, replace s plus 1. Wherever s is there, no, replace s plus 1. So here s is there, s plus 1, and this plus 1 is also as it is. S is there, s plus 1. Here also s square is there, s plus 1 raised to 2 plus 36. Right. Why we are replacing this as a s plus 1? Because a is minus 1. S minus of minus 1. So this is s plus 1. So where you are replacing s as s plus 1? In f bar s. So what is f bar s? F bar s is Laplace transform of a function. So here Laplace transform of function is 1 by 2 into 1 by s plus s divided by s square plus 6 square. So here you replace s as s plus 1 because we want Laplace transform of e raised to minus t into cos square 3t. So cos square 3t is nothing but f of t. We have taken cos square 3t as a f of t, right? A function f of t is multiplied by e raised to at. Change s to s minus a. So a is minus 1. Change s to s plus 1. So we will get the required answer. Now move on to next example. Find the Laplace transform of 1 plus 3t e raised to 2t raised to 2. So first, what is f of t? Let f of t is equal to 1 plus 3t e raised to 2t raised to 2. So how it is like? A plus b whole square. A plus b whole square. A plus b whole square is a square plus 2ab plus b square. So a is 1, b is 3t e raised to 2t. This is b, this is a, and this is b. So 1 square 1, right? And 3t e raised to 2 t raised to 2 is 3 raised to 2 9 t raised to 2 t square. E raised to 2t raised to 2 is e raised to 4t, means a square b square over. Next is plus 2ab. 2 into a is 1 and b is 3t e raised to 2t. So you'll get this as 6t e raised to 2t. So this is expansion of this 1 plus 3t e raised to 2t raised to 2. Apply a plus b whole square. So what is a plus b whole square? A square plus 2ab plus b square. A is 1, b is 3t e raised to 2t. Right? Now apply Laplace transform to this. So Laplace transform of f of t is equal to Laplace transform of 1 and this plus 6. This is as it is. Laplace transform of t e raised to 2t plus 9 into Laplace transform of t square e raised to 4t. Right? Now we know what is Laplace transform of 1. So 1 by s, no problem. So we need to find these two. We need to find these two, right? So for this, I'll apply, to find this, I'll apply shifting property. I'll apply shifting property. Means e raised to at into f of t. E raised to at into f of t. I'll apply shifting property. And for this also, I'll apply shifting property, right? Means here f of t is t and here f of t is t square, right? So we know that Laplace transform of t raised to n is n factorial divided by s raised to n plus 1. right? Then what is Laplace transform of t? 1 factorial divided by s raised to n plus s raised to 1 plus 1 is 2. S raised to 1 plus s raised to 1 plus 1 is 2, right? Means you will get here as Laplace transform of this t will be 1 divided by s raised to 2, and Laplace transform of t square will be 2 divided by s raised to 2 plus 1 means here 3 s raised to 3 multiplied by e raised to 2t multiplied by e raised to 2t multiplied by e raised to 4t. So here s changes to s minus 2 and here s changes to s minus 4. Here s changes to s minus 4, right? So here f Laplace transform of f of t, this is equal to Laplace transform of 1 is 1 by s plus this 6 will be as it is. Laplace transform of this t is 1 divided by s square. Change s to s minus 2. We are applying shifting property. So 1 divided by s minus 2 raised to 2 plus this 9 will be as it is. Laplace transform of t square will be 2 divided by s cube, 2 divided by s raised to 3, change s to s minus 4, change s to s minus 4. So 2 divided by s minus 4 raised to 3. So this 9 will be as it is, right? So why? Because we are using shifting property. We are using shifting property. So according to that, a function f of t, if it is multiplied by e raised to at, change s to s minus a. Where? In f bar s. Change s to s minus a. Where? In f bar s. So according to that, you change s to s minus 2, s to s minus 4, right? Now you can simplify this if you want. 1 by s plus 6 divided by s minus 2 raised to 2, because 6 into 1 here 9 into 2 is 18. 9 into 2 it is what here 18 divided by s minus 4 raised to 3. So this will be as it is, right? So what is Laplace transform of t? 1 by s square. Laplace transform of t square will be 2 divided by s cube, right? So Laplace transform of t e raised to 2t means a function f of t is t multiplied by e raised to at. Change s to s minus a is to change s to s minus 2, right? Here f of t is what here? T square. Only for this I am explaining. F of t, for f of t will be t square. So f of t is t square. So Laplace transform of f of t or t square, this is equal to 2 divided by s cube. So this f of t is multiplied by e raised to 4t. So change s to s minus a. A is 4. S to s minus 4. So 2 divided by s minus 4 raised to 3. Right. So we have used these two results in this. Now move on to next example. Find the Laplace transform of t cos at. Right? Now, we know that Laplace transform of t raised to n f of t is equal to minus 1 raised to n d raised to n divided by ds raised to n f bar s. Right? Now, f comparing these two, so f of t is cos at, obviously, and in place of n we have 1. It is understood. T raised to n is there. T is there. We can write this t as t raised to 1. So comparing these two, n is equal to 1, right? So n is equal to 1 and f of t is cos at, right? So once if we know what is f of t, so we can find f bar s. We can find f bar s. So first find f bar s. So first find f bar s. Right. First find f bar s. So f of t is equal to cos at. F of t is cos at. Then f bar s will be Laplace transform of f of t. So what is Laplace transform of cos at? So Laplace transform of cos at is s divided by s square plus a square. right? We want Laplace transform of t cos at. So Laplace transform of t cos at will be minus 1 raised to 1 d raised to 1 or d raised to n divided by ds raised to n. So n is 1. So you'll get this as d by ds. 1 is, it is understood, d by ds. F bar s is s divided by s square plus a square. Right? Now this minus will be as it is. D by ds means what here? Differentiate this with respect to s. Differentiate this with respect to s. Only we have d by ds means only one time you differentiate with respect to s. Numerator, s term we have. Denominator, s term we have. Means apply quotient rule, u by v rule. Apply u by v rule, right? So denominator raised to 2 s square plus a square raised to 2. So denominator s square plus a square as it is. Differentiate numerator. S with respect to s is 1 minus numerator as it is denominator s square plus a square, you differentiate this with respect to s. So a is constant 0 and differentiation of s square is 2s. Differentiation of this s square is 2s. Now simplification, right? S square plus a square minus s into 2s is 2s square whole divided by s square plus a square raised to 2, right? Now s square minus 2s square is minus s square plus a square divided by s square plus a square raised to 2. So multiply this negative sign. So minus into minus is plus s square, plus into minus is minus a square divided by s square plus a square raised to 2. Thus Laplace transform of t cos at is equal to s square minus a square divided by s square plus a square raised to 2. So this will be the required answer, right? Now move on to next example. Find the Laplace transform of t raised to 5 e raised to 4t cos hyperbolic 3t. It is a product of three functions. Hyperbolic functions, exponential, and t raised to 5 means it is like a polynomial. Product of three functions. So f of t is equal to t raised to 5 e raised to 4t cos hyperbolic 3t, right? So t raised to 5, you keep this as it is, e raised to 4t also as it is, hyperbolic function. So we have a standard property. We can convert this hyperbolic functions into exponential. So use that property and take advantage. So we can write that cos hyperbolic 3t as e raised to 3t plus e raised to minus 3t divided by 2. Why plus? Because cos. If cos plus, if sine minus, right? So cos hyperbolic e raised to 3t plus e raised to minus 3t divided by 2. Take this 2 outside, t raised to 5 into divided by 2. Denominator, right? So t raised to 5, denominator divided by 2, and multiply e raised to 4t to these two terms, e raised to 4t into e raised to 3t. Theory of indices, base is same. 4t plus 3t is 7t. So e raised to 7t. This plus sign is as it is. E raised to 4t into e raised to minus 3t. So 4t minus 3t is e raised to t. Now 1 by 2 as it is, t raised to 5 e raised to 7t plus t raised to 5 e raised to t. So we want Laplace transform of this. So Laplace transform of f of t, this is equal to 1 by 2 Laplace transform of t raised to 5 e raised to 7t plus Laplace transform of t raised to 5 e raised to t. Take this as a equation 1, right? So first we need to find what is Laplace transform of t raised to 5. Then Laplace transform of t raised to 5 e raised to 7t, right? So we know that Laplace transform of t raised to n is n factorial divided by s raised to n plus 1. So Laplace transform of t raised to 5 will be 5 factorial because n is 5. 5 factorial divided by s raised to n plus 1. 5 plus 1 will be 6. What is Laplace transform of e raised to 7t t raised to 5? Change s to s minus 7. Use shifting property. Change s to s minus 7. Why s minus 7? In place of a, we have a 7. So change s to s minus 7. Where we need to change? So here, where we need to change? So in this, wherever s is there, replace s minus 7. So 5 factorial divided by s minus 7 raised to 2. Similarly, Laplace transform of e raised to t raised to 5 is 5 factorial divided by s minus 1 raised to 6. Why s minus 1? Because e raised to at, a is 1. In place of a, we have a 1 and we are using shifting property here, right? Now substitute this in equation 1. 1 by 2 into bracket 5 factorial means 120 divided by s minus 7 raised to 6 plus 120 divided by s minus 1 raised to 6, right? Take this 120 outside because 120 is common for both the terms. Take it outside. 120 divided by 2, 2 ones are 2 6 are. So you'll get this as 60 into 1 divided by s minus 7 raised to 6 plus 1 divided by s minus 1 raised to 6. So this will be the required answer, right? Now move on to next example. Find the Laplace transform of t square sine 80. T square sine 80. So compare this with Laplace transform of t raised to n f of t. Then what is n? N is 2. And what is f of t? Sine 80, right? So we know that Laplace transform of t raised to n f of t, this is equal to minus 1 raised to n nth derivative of f bar s, or dn divided by ds raised to n f bar s. So here n is 2. So f of t is sine 80. Then Laplace transform of f of t is f bar s. So f bar s is equal to Laplace transform of sine 80, that is a divided by s square plus a square. It is a standard result, right? We want Laplace transform of t square sine 80. So n is 2 minus 1 raised to 2 because n is 2, d raised to 2 divided by ds raised to 2, or d square divided by ds square of f bar s. F bar s is a divided by s square plus a square, right? So why in place of, so why here 2? Because n is 2. So here also 2, here also 2, here also 2, right? Now minus 1 raised to 2. Minus 1 raised to 2 means here multiply minus 1 2 times. So minus 1 into minus 1 will be plus 1, or multiplying this minus 1 even times you'll get plus 1, minus 1 odd times minus 1. So 2 is even, so you'll get this as a plus 1 over, right? Now we want d square divided by ds square, means differentiate this with respect to s. 2 is there, 2 means twice. You differentiate this with respect to s 2 times, right? So first we'll write this as d by ds of a divided by s square plus a square. So first differentiate this with respect to s. This will be as it is with respect to s, right? This a is constant. How it is like? Differentiation of 1 by x. Differentiation of 1 by x is minus 1 upon x square. So in the same way, so differentiating this, you'll get this as minus 2s divided by s square plus a square raised to 2, right? Now d by dx of minus 2as divided by s square plus a square raised to 2. So we need to find. So Numerator also we have s term, denominator also we have s term. So apply u by v rule, right? Now denominator raised to 2. So you'll get this as s square plus a square raised to 4, right? Now, so this will be as it is, denominator, as keep this as it is, differentiate numerator. Minus 2as with respect to s is minus 2a, minus numerator will be as it is minus 2as, and differentiate denominator, s square plus a square raised to 2 is there. With respect to s means 2 into s square plus a square. S square plus a square with respect to s is 2s, right? Now from both the terms, s square plus a square is common, take it outside, and we can take here 2a also common, take it outside. Now s square plus a square, 2a divided by s square plus a square raised to 4, take it outside. So inside bracket will be s square plus a square raised to 2 is there. 1 outside means you'll get s square plus a square with this negative sign. And here 2a outside, left with what here? 2 into 2 is 4s. 2 into 2s is 4s. And this minus s will be what here? 4s square. You'll get here 4s square because this is outside and this 2a is outside. Here minus s left. Minus s into 2 into 2s will be 4s square. Minus 4s square with, and here our negative sign is there. Minus into minus is plus 4s square. Right. Now 1s square plus a square get cancels with this. So we'll get here as this 2a divided by s square plus a square raised to 3 because 1 get cancels. And here minus s square minus a square plus 4s square. 4s square minus s square is 3s square minus a square. Right? So Laplace transform of t square sine at, this is equal to 2a 3s square minus a square divided by s square plus a square raised to 3. So this will be the required answer. Right? Now move on to next example. Find the Laplace transform of 1 minus e raised to minus at divided by t. So how it is like? F of t divided by t. So Laplace transform of f of t divided by t. So we know that Laplace transform of f of t divided by t is integration from s to infinity f bar s, right? So comparing these two, first find f of t. So f of t will be 1 minus e raised to minus at. This is f of t. We want f bar s. We know what is f of t. Then easily we can find f bar s. So f bar s will be Laplace transform of f of t. So f bar s is Laplace transform of 1 minus e raised to minus at. So we can write this as by taking Laplace transform both sides by taking Laplace transform to both the terms. So first Laplace transform of 1, this negative sign as it is, Laplace transform of e raised to minus at. What is Laplace transform of 1? 1 by s minus, what is Laplace transform of e raised to minus at? 1 divided by s plus a. 1 divided by s plus a. Right? Now Laplace transform of f of t is 1 minus e raised to minus at divided by t. This is equal to integration from s to infinity 1 by s minus 1 upon s plus a, and integrate this with respect to s because we are using the formula. So what is that property? Laplace transform of f of t divided by t. This is equal to integration from s to infinity f bar s ts. So f bar s is 1 by s minus 1 upon s plus a into ds. Integrate this with respect to s. Now integrate this with respect to s. So integration of 1 by s with respect to s is log s minus integration of 1 upon s plus a is log of s plus a. Limits varies from s to infinity. So log m minus log n, log m minus log n. So this is log m by n. So log m is s, n is s plus a. So log s divided by s plus a. Now substitution of this limit. So before substitution, so I will take, because infinity term is there, right? Upper limit is infinity. So here also yes term, here also yes term. So you'll get infinity only. So for that, so we can simplify here. S will be as it is numerator, and denominator take s as common. So you'll get inside as 1 plus a by s. Multiply this s to this bracket. So you'll get same thing as s plus a, right? And this s get cancels. Limits s to infinity, right? So log 1 minus log 1 minus log s divided by s plus a. S divided by s plus a, because so substitute upper limit as infinity. In place of s you substitute infinity. So 1 divided by 1 plus a divided by infinity. So a divided by infinity will be 0. 1 plus 0 is 1, right? 1 by 1 is 1. So you'll get this as log 1, and in place of s you substitute s. So you'll get this as s divided by s plus e, right? So substituting upper and lower limit. So substituting upper limit, you'll get this as log 1, and substituting lower limit, you'll get this as log s divided by s plus a. So log 1 is 0. So minus sign will be as it is. So we can write this log s divided by s plus a, log m by n, log m, log s minus log n, log s plus a. Multiply negative sign. So minus into minus is plus. So this is equal to log s plus a minus log s, right? Again log m minus log n. So log s plus a divided by s. So this will be the required answer. Now move on to next example. Very important one. Many times appears in question paper, and here in place of a and b, so a and b are constants, so they may give in place of a and b as numerical value like 2 3 4 5 5 4 3 2, like that. Here find the Laplace transform of cos at minus cos bt divided by t, right? So f of t is equal to cos at minus cos bt. So how it is like? Laplace transform of f of t divided by t, right? So f of t will be comparing with that. So f of t will be cos at minus cos bt. So f bar s is equal to Laplace transform of function. F of t is this. Laplace transform of f of t will be Laplace transform of cos at minus cos bt. So Laplace transform of cos at is s divided by s square plus a square, minus Laplace transform of cos bt is s divided by s square plus b square. So we want Laplace transform of f of t divided by t. So this is equal to integration from s to infinity f bar s with respect to s. So f bar s is s divided by s square plus a square minus s divided by s square s square plus s divided by s square plus a square minus s divided by s square plus b square. Integrate this with respect to s, right? Now see, denominator we have s square, numerator we have s. So differentiation of this will be 2s. Differentiation of this will be 2s. Then we can apply here integration of f dash x divided by f of x with respect to x will be log f of x, right? So for that I want 2 here. So multiply 2. Whatever we have multiplied, we have to divide 2, right? So next step will be 1 by 2. Why 1 by 2? Because we are multiplying numerator with 2. So whatever we have multiplied, we have to divide. So integration from s to infinity, we have multiplied 2s divided by s square plus a square, minus we have multiplied 2s divided by s square plus a square. For both the terms we have multiplied 2. So whatever we have multiplied, we have to divide because we need to balance the equation. So here divide 2. So 1 by 2. So this is nothing but log s square plus a square, and this is nothing but log s square plus b square. Limits varies from s to infinity. Limits s to infinity. So log m by n. So 1 by 2 log s square plus a square divided by s square plus b square. Limits s to infinity. So infinity term is there. So for that, take s square common and cancel, because numerator also s square term you take common, denominator also you take s square common, both numerator and denominator s square, so get cancels. So after simplifying, so you'll get here as 1 by 2 log 1 plus a square divided by s square divided by 1 plus b square divided by s square. Limits varies from s to infinity. Now substitute upper limit to this. In place of s, you substitute infinity. So you'll get this as this 1 by 2 will be as it is. Substituting infinity in place of s, so you'll get log 1 minus substituting in place of s as s only, you'll get this as log s square plus a square divided by s square plus b square. So log 1 is 0. So we can write this as minus, this negative sign will be as it is, log s square plus a square minus log s square plus b square. Multiply this negative sign, 1 by 2 log s square plus b square minus log s square plus a square. Why? Because this minus into minus is plus. Taking positive term as a first, you will get this term as first, next as this. So 1 by 2 log s square plus b square divided by s square plus a square. Why? Log m minus log n is log m by n. So 1 by 2. So we can write this as log s square plus b square log s square plus b square divided by s square plus a square raised to 1 by 2. Why? Because n log a will be log a raised to n using this, right? So 1 by 2 means we can write this as log square root. 1 by 2 means square root of s square plus b square divided by s square plus a square. So this is Laplace transform of f of t divided by t. What is f of t? Cos at minus cos bt. So Laplace transform of cos at minus cos bt divided by t is log square root of s square plus b square divided by s square plus a square, right? So today I'll stop here only. So tomorrow, so next class I will continue, right?